Hi, all. This is the second class of Module 2 manufacturing process. In this section, I am going to discuss about oxy fuel gas welding process, OFW welding process. So basically, this is a gas welding process, oxy fuel gas welding process. It is also known as OFW welding process, or otherwise known as oxy acetylene gas welding process, ORC. So oxy fuel gas welding process is basically a gas welding process. In oxy fuel gas welding process, heat required for welding is obtained by burning acetylene gas in the presence of oxygen. That's a very important point. In oxy fuel gas welding process or OFW welding process, the heat required for welding is obtained by burning acetylene gas in the presence of oxygen. Additional metal, that is known as filler material, which is added to molten weld pool in order to increase the metallurgical strength of welded joint. Flux is also used during welding process to prevent oxidation, and also flux acts as a cleaning agent, remove impurities from the welded joints. The temperature of oxyacetylene flame is in its hottest region is about 3200 degrees Celsius. So during the one of the commonly using oxy gas welding process is the oxyacetylene welding process. One of the most applicable oxy gas welding process is the oxyacetylene welding process. In oxyacetylene welding process, the heat required for welding is obtained by burning acetylene gas in the presence of oxygen. See, while acetylene gas is burning in the presence of oxygen, there will be primary combustion and secondary combustion take place. During primary combustion, oxygen combine with the carbon of acetylene and form carbon monoxide. You can see 2C2H2 plus 2O2 gives 4CO plus 2H2. So during primary combustion, oxygen combine with the carbon of acetylene and form carbon monoxide and hydrogen. Then during secondary combustion, carbon monoxide and hydrogen react with oxygen to form carbon dioxide and water and heat. That heat is used for melting base metal to be jointed. So combustion of oxygen and acetylene gas consists a primary combustion and a secondary combustion. Primary combustion consists combustion of oxygen with the carbon of the acetylene form carbon monoxide and hydrogen. Secondary combustion, carbon monoxide and hydrogen again react with oxygen to form carbon dioxide, water and heat. So during welding process, that flame is introduced into the base metal where we have to form a joint, and additional material that is known as filler metal also added to molten weld pool, which will increase the strength of the welded joint. So what are the types of flames in oxyacetylene welding process? It's a very important topic, usually asked in university examination. Explain about types of flames in oxy gas welding process or oxyacetylene welding process. There are three types of flames: neutral flame, oxidizing flame and carburizing flame. So first one, neutral flame. Okay, explain based on speaker. See, in neutral flame, oxygen and acetylene are mixed in equal proportions in blow pipe. In neutral flame, oxygen to acetylene ratio is 1:1. So temperature of the flame is about 3260 degrees Celsius. That's the important point. The temperature of the flame is 3260 degrees Celsius. And in the case of neutral flame, as a distinct inner cone, clear round cone, you can see that neutral flame consists a distinct inner cone which is light blue color, clear round inner cone which is light blue color. It is surrounded by an outer flame envelope which is dark blue than inner cone. That is a characteristic of the neutral flame. Neutral flame consists an inner cone. It is clear round cone and a lengthy flame, light blue color. It is surrounded by outer flame, which is dark blue color than cone. Inner cone. See, what is the application of a neutral flame? See, neutral flame is used to weld most of common material like mild steel, cast iron, stainless steel, copper and aluminum. That's the application of the neutral flame. See, actually, neutral flame have one advantage. Neutral flame does not have a bad effect on the base metal. That is, the metal is not oxidized. That's the important point of neutral flame. There is no metal is oxidized while we are using neutral flame. Okay. Second one is oxidizing flame. See, in the case of oxidizing flame, excess of oxygen over acetylene as the gas comes out of the nozzle. In the case of oxidizing flame, the oxygen gas is excess over acetylene when the gas mixture comes out of the blowpipe. In oxidizing flame, oxygen to acetylene ratio is 1.5:1. Oxygen to acetylene ratio is 1.5:1. The temperature of the flame is in the order of 3482 degrees Celsius. See why this high temperature is in the presence of oxygen. So in the characteristics of a flame is the flame has an inner cone, pointed and dark in blue color and a shorter outer cone. That's the characteristic of the oxidizing flame. The flame has an inner cone, pointed and dark blue color and a shorter outer cone. See, the flame has an oxidizing effect on metal which prevent evaporation of zinc tin in brass welding or bracing. That's a very important point. The oxidizing flame has an oxidizing effect on metal which prevent evaporation of zinc or tin in brass welding or bracing. So it has high application. Oxidizing flame have high application in brace welding, bracing, etc. So useful for welding brass and for bracing ferrous material. That's one of the main application of the oxidizing flame. And last one is the carburizing flame. Carburizing flame, it is also known as reducing flame. See, in the case of carburizing flame, it receives an excess of acetylene over oxygen in the blowpipe. We have excess of acetylene gas over oxygen in the blowpipe. The oxygen to acetylene ratio is 0.9:1. That's important point, 0.9:1. The temperature of the flame is in the order of 3037 degrees Celsius. See, reducing flame is recognized by an acetylene feather. You can see the figure. This is an acetylene feather having pearl green color existing between inner cone and outer cone. See, in the case of carburizing flame or reducing flame, there is a intermediate cone, that is an acetylene feather, which is pearl blue color, which is existing between the inner cone and outer cone. See, commonly use of carburizing flame are used for stellite, hard facing, Lindy welding of steel pipe and flame cleaning. For this purpose, commonly reducing flame or carburizing flame is used. So these are the three classification of flames in the case of oxy-acetylene welding process. Very important topic. There is a high chance for asking university question that explain about what are the different types of flame in oxy-acetylene gas welding process. So there are three types of flame: neutral flame, oxidizing flame and carburizing flame. See, neutral flame is the most commonly used flame. So mild steel we are using neutral flame. Copper deoxidized we are using neutral flame. Brass welding oxidizing flame. For cast iron welding neutral flame. Stainless steel welding using neutral flame. Aluminum we are using neutral flame. Stellite we are using carburizing flame. So these are the different type of metal and different type of flame used for oxyacetylene welding process. This is very important. You have to remember, mild steel we are using neutral flame, copper deoxide using neutral flame, brass oxidizing flame, cast iron using neutral flame, stainless steel using neutral flame, aluminum using neutral flame, stellite using carburizing flame. Okay, so this is the figure of oxy gas welding process. Here, oxyacetylene welding process. So in oxyacetylene welding process consist we have oxygen cylinder and acetylene cylinder. In an oxyacetylene welding process, the acetylene gas is burning in the presence of oxygen. That heat is used for welding the base metal to be jointed. So oxyacetylene gas welding process consists an acetylene cylinder and an oxygen cylinder. So acetylene cylinder, it should be clearly here, acetylene cylinder which is maroon in color, and acetylene cylinder have a capacity of 3.5 meter cube to 8.5 meter cube, which is acetylene cylinder which is maroon in color, which have a capacity of 3.5 meter cube to 8.5 meter cube, and the acetylene gas is stored inside the acetylene cylinder in a pressure of 15 kilogram per centimeter square. Okay, then this acetylene hose have maroon in color also. Then oxygen cylinder which is black in color, which have the capacity of 7 meter cube, and oxygen cylinder, oxygen is storing at a pressure of 120 to 150 kilogram per centimeter square. Oxygen hose is also in black in color, and this is known as blow pipe. Inside this blow pipe, oxygen and acetylene gas are mixing. So controlling the flow of acetylene gas and oxygen gas, there is a control valve, acetylene control valve and oxygen control valve. So this is a setup for oxyacetylene welding process. So this is known as welding torch and this is known as blow pipe. Okay. So next one is filler material used in oxy gas welding process. Okay. The filler material used in oxy gas welding process. So what is the purpose of a filler material? See, filler material are the additional material which is adding to molten weld board in order to increase the metallurgical strength of the welded joint. The filler material have same or nearby same composition as that of base metal to be welded. See, this is a welding setup. We have two base metal to be jointed. This is a welding torch. We are adding filler material. See, filler material are classified into two types. That is, all filler material are consumable filler material. It will get melted and the metal is transferred to the molten weld pool and finally get solidified with the welded joint and increase in the strength of the welded joint. See, this consumable filler material are classified into two types. That is, first one, bare or coated with flux. Bare or coated with flux. See, when we are using bare filler rod, flux will be additionally required to add on the molten weld pool. Coated filler material have a chemical coating over the filler material. During the welding process, it will undergo chemical reaction due to the temperature of the welding process and producing a flux and also producing a shielding gas. So what's the importance of the flux in the welding process is that produced flux that will produce a slag and that will float over the molten weld pool and prevent oxidization, and it will act as a barrier from surrounding atmosphere, and also the slag that will act as a cleaning agent. It will absorb impurities and foreign particles in the molten weld pool. So these are two classification of filler rod, that is bare filler rod and flux coated filler rod. When we are using bare filler rod, there is a need to add flux separately over the molten weld. Then the second classification, flux coated filler rod, there is no need to add the flux in the molten weld pool. The flux undergo chemical reaction and produce the filler material. Flux undergo chemical reaction and produce the slag that will float over the molten material and remove the oxides and impurities from the molten material. So that's the importance of flux in the case of uh, gas welding process. So what is the importance of flux in the case of a gas welding process? That's very important. Flux is very important. While in gas welding process, we are adding flux. See, flux is actually a chemical components that is available in paste, powder, and liquid form. See, this flux undergo chemical reaction during welding process and produce slag. That's the important point. Flux undergo chemical reaction during welding process and produce slag. Slag have lighter weight when compared to molten material. As slag have lighter weight, the slag will float over the molten material. Slag that will absorb the oxides, remove the oxides and impurities in the molten material, and it acts as a barrier from surrounding atmosphere to protect the surrounding molten material from surrounding atmosphere. So after the welding has been get solidified, the slag will be the top of the welded joint. It can be removed by chipping or other machining operation or something. So that's the importance of this flux in the gas welding process. So flux that are available in paste, powder, and liquid form. During welding process, the flux undergo chemical reaction producing slag. The slag have lighter weight when comparing to molten material. The slag that will float over the molten material and it will absorb the oxides and impurities from the molten material and it acts as a barrier between the surrounding atmosphere and molten material and protect the molten material from surrounding atmosphere. And after the welded joint gets solidified, the slag can be removed from the top of the welded joint by chipping or something, etc. Okay. Okay. Welding technique of oxy-acetylene welding process. This is a very important topic usually asking in university examination. Welding technique of oxy-acetylene welding process. There are two welding technique on oxy-acetylene welding process. Leftward welding technique, also known as forehand technique. Rightward welding technique, also known as backhand technique. So first of all, we are going to discuss about leftward welding technique. It is also known as forehand technique. So I will show the figure and we can explain. Okay. Leftward welding technique, it is known as forehand welding technique, or otherwise it is known as forward welding technique. There are three names: leftward welding technique, forehand welding technique, or otherwise known as forward welding technique. See, leftward welding technique is the most widely used welding technique in the case of oxy-acetylene welding process. In leftward welding process, welding start at the right hand edge of the welding job and proceeds towards left. Welding start at the right hand edge of the right hand edge means here. Welding start at the right hand edge of the welding job and proceeds towards left. See, the blow pipe is held at an angle of 60 to 70 degree. You can see that the blow pipe is held at an angle of 60 to 70 degree and the filler rod is held at an angle of 30 to 40 degree to the weld line. The welding blow pipe, during welding process, the welding blow pipe follow the filler material and the welding flame is directly away from deposited weld metal. So that's the case of the leftward welding technique. So once more I will explain. See, leftward welding technique, it is also known as forehand welding technique or forward welding technique. In the case of leftward welding technique, welding starts at right hand edge of the welding job and proceeds towards left. Blow pipe is held at an angle of 60 to 70 degree and filler rod is held at an angle of 30 to 40 degree with the weld line. During welding process, the blow pipe follow the filler rod and the flame is away from the deposited metal. So this is the case of leftward welding technique. Then rightward welding technique. Rightward welding technique, it is also known as backhand welding technique or backward welding technique. So we can explain with the figure. In rightward welding technique, backhand welding technique or backward welding technique, welding start at left hand edge of the welding job. Welding start at left hand edge of the welding job and proceeds towards right. So the blow pipe that is held at an angle of 40 to 30 degree and filler rod is held at an angle of 30 to 40 degree. Blow pipe is held at an angle of 40 to 30 degree. You can see 40 to 30 degree and the filler rod is held at an angle of 30 to 40 degree with the welding line. In this case, during welding process, filler rod follow the blow pipe and the flame that is directed to the deposited weld metal during welding process. That's the case of right hand welding technique. See, this right hand welding technique have one importance. It is used to weld thick steel plate above 5 ohm. Lindy welding process of steel shell also right hand welding technique is used. So this is the two welding technique in the case of oxy-acetylene welding process. Leftward welding technique, forehand welding technique or forward welding technique. Second one, rightward welding technique, backhand welding technique or backward welding technique. Okay. So this is all about oxy gas welding process or oxy-acetylene welding process. Oxy gas means oxy fuel welding process or oxy-acetylene welding process. Fuel is the acetylene gas. Okay. Thank you.